first section of chapter 5 deals with functions and their inverses. A function is where each x has one and only one y. And there is a vertical line test if you're looking at the graph of a function, meaning that no vertical line can go through a graph and hit it in more than one place. If that happens, then it's not a function. A function is a one-to-one function, meaning each x has one and only one y, if then each y has one and only one x. And that means it has a horizontal line test to determine if it's one-to-one. So a function that is one-to-one would look like this, perhaps. That's a function because the vertical line tests, no matter where you move this vertical line, it is only going to hit this in one place. And it is a one-to-one function because if you put a horizontal line in and move this up and down, it is still only going to hit it in more than one place. Another function that is a one-to-one function would possibly be something that goes like this. Because now on your vertical line test, or determine if it's a function, there is no place where this is going to hit more than one spot, and horizontally the same thing. A function that looks like this, or let's go first off, a function that is really not a function. Get rid of those two. Here's something that is not a function. Actually, looks like a circle, because when you draw a vertical line through here, it's going to hit it in more than one spot. Or this type of thing. That is not a function. A one-to-one function, say we have this. There, it is a function because it passes the vertical line test. But if we take our horizontal line and put it, it hits it in more than one spot. So because this x and that x have the same y value, it's not a one-to-one. The reason that is important is because of this right here, the inverse, or the inverse function. If you have a function, no matter what it is, f to the -1 power of x means find the inverse, or the inverse of that function. So if we have f of x equals 3x minus 7, if we want to figure out what the inverse is, then what you have to do to find the inverse is solve for x and then rewrite in function form. And so if you're going to take 3x minus 7, you would have y equals 3x minus 7, and then to solve for x, you would add 7. Y plus 7 equals 3x. Then divide by 3. And x equals 1/3 y plus 7/3. And so now this would be the inverse. But if we're going to write it in function form, it would then turn into 1/3 x plus 7/3. So now 3x minus 7 and 1/3 x plus 7/3 are inverses of each other. Then, if you have a function and you have its inverse, and this can only happen when the function is 1-to-1. If that is the case, then the domain of the function is the range of its inverse. And the range of the function is the domain of its inverse. And finally, to prove things are inverses of each other. One is you can take the function and figure out what the inverse is. But if you're given two things and it asks you, two functions, and it asks you to prove that they're inverses, you have a couple of options. One is you can take f composition g of x, or you can take g composition f of x. In either case, if you get just x, when you simplify those two things, then those functions are inverses of each other. So we know these are already functions, but just to show that you can prove them, that they're inverses, if you were given f of x is 3x minus 7 and g of x equals 1/3 x plus 7/3, we have to prove they're inverses. So we can do f composition g of x or g composition f of x. It doesn't matter which one you do. You don't have to do both of them. You only need to do one. We here today are going to do both of them just so that you see it doesn't matter which route you take. So if we're going to take f composition g of x, we're taking that g function and substituting it into the f function for the variable, and you would get 3 times 1/3 x plus 7/3, and then minus 7. Distributing the 3 to both of these two things would get you x plus 7 minus 7. And simplifying plus 7 minus 7 is just x. And so because f composition g of x is x, these two functions are inverses of each other. If we work the other route and take g composition f of x, we are going to take that function and substitute it in for x into the g function. So then you would have 1/3 of 3x minus 7 plus 7/3. And again, distributing the 1/3, in this case, it would be x minus 7/3 plus 7/3, and negative 7/3 and positive 7/3 is 0, so you're left with just x. And so now, because g composition f of x is also just x, they are inverses. Like I said, you don't have to prove both, you only have to be able to prove it one way or the other. And finally, if you look on page number 324 of your book, about 1/3 of the way down the page, there's a red box for guidelines for finding the inverse in simple cases, which most of the things you're going to be dealing with in here will be simple cases. You can verify that f is a 1-to-1 function throughout its domain. And to do that, you just use your horizontal line test. The second thing is to solve the equation y equals f of x for x in terms of y to obtain a new equation. That's where you're just going to solve for the x variable, get x by itself, and then rewrite it. And the third thing is to verify the following two conditions: either f composition g of x or g composition f of x equals just plain x. And if you can do those things, then you can verify that something is an inverse of another one. And now you can start working on the assignment for section 5.1.